We now discuss the solution of a problem from the section Differential Calculus, and the problem is related to the maxima and minima of a function of a single real variable. This question has appeared in the joint entrance examination main held on 29th June 2022 in the shift 1. The given question is a wire of length 22 meters is to be cut into two pieces. One of the pieces is to be made into a square and the other into an equilateral triangle. Then the length of the side of the equilateral triangle so that the combined area of the square and the equilateral triangle is minimum is, we are given four options. Option A, option B, option C and option D. We are given a wire of length 22 meters and it is cut into two pieces. One of the pieces is made into a square and the other piece is made into an equilateral triangle. Required to find the length of the side of the equilateral triangle when the combined area of the square and equilateral triangle is minimum. We now discuss the solution of the problem in detail. We are given a wire of length 22 meters and it is cut into two pieces. One of the piece is made into a square and the other into an equilateral triangle. Agreed. Let y be the side of the square and x be the side of the equilateral triangle. Then in that case, the perimeter of the square is 4y. The perimeter of the equilateral triangle is 3x. Therefore, 4y plus 3x is equal to 22 meters. Then 4y plus 3x is equal to 22. This implies y is equal to 22 minus 3x by 4. And we have the area of the square is y square and the area of the equilateral triangle is root 3 by 4 x square. Then the combined area, capital A, is given by y square plus root 3 by 4 x square. Right. So we take A and substitute 22 minus 3x by 4 for y. So A is equal to 22 minus 3x by 4 square, that is y square, plus root 3 by 4 x square. Thus, capital A is a function of x alone. Agreed. What is the question? The question is required to find x. What is x? The length of the side of the equilateral triangle. When capital A, the combined area of the square and equilateral triangle is minimum. So that means the problem is reduced to a maxima and minima problem of a function of a single real variable. We continue in the next slide. We have capital A is equal to 22 minus 3x by 4 whole square plus root 3 by 4 x square, and our job is to find x when A is minimum. To talk about maxima minima, we differentiate A with respect to x and equate it to 0 and find the critical points. Differentiating with respect to x, then dA by dx is equal to 2 times 22 minus 3x by 4, and the derivative of 22 minus 3x by 4 with respect to x is minus 3 by 4 plus root 3 by 4. The derivative of x square is 2x. After cancellation, you will get 8 as the LCM. So take the LCM 8. Then the first one is 3 times 22 is minus 3 times 22 is minus 66. Minus 3 into minus 3x is plus 9x. And here a 2 is left. 4 times root 3x. So that is precisely equal to minus 66 plus in brackets 9 plus 4 root 3 into x by 8. We equate dA by dx is equal to 0 to get the critical points. dA by dx is equal to 0 will give you x is equal to 66 by 9 plus 4 root 3. That is the critical point. We take dA by dx and differentiate again with respect to x. D square A by dx square is equal to, this you will get this as 9 plus 4 root 3 by 8, because it is minus 66 by 8 plus 9 plus 4 root 3 by 8 into x. It is a plus bx. After differentiation, it will be b. That is 9 plus 4 root 3 by 8, which is positive. This is positive even for x is equal to 66 by 9 plus 4 root 3. Thus, a is minimum for this value of x. Right. Thus, a is minimum when x is equal to 66 by 9 plus 4 root 3. So, we have to require to find the value of x when a is minimum. So, the answer is 66 by 9 plus 4 root 3. That is x. Let's look at our options. Our answer appears against option B. Therefore, the answer to this question is option B. That is the detailed discussion of the solution of the problem from the differential calculus, which is related to the maxima and minima. And it is a very simple, straightforward question. And I am sure that you have understood the solution of this problem. And I wish you all the best. Thank you.